Okay, so we're going to do some more sample problems here on number 14. Number 14 says tax returns. And again, I read the claim and I ignore the rest. The first thing is I read the claim. The claim says, among those who file tax returns, less than one half file them through an accountant or other tax professional. I don't care about the test. I don't care about the survey. I don't care about the rest of the data. I don't care about the statistics. I'm just going to focus on that claim. That claim again says, among those who file tax returns, less than one half file them through an accountant or other tax professional. I'm going to first write my claim in symbolic form. What is one half? Is one half a mean or is one half a proportion? It's a proportion. Good. So my claim is that the proportion is what? Less than one half. And I can write in one half or I can put 0.5. Same difference, right? So now that I've established my claim in symbolic form, I'm ready to write my null hypothesis. We know that our null hypothesis can only be equal. We don't have a choice. So our null hypothesis is going to be that P is equal to 0.50. Given that my claim says less than and my null says equal to, my alternative hypothesis is going to now be P is less than one half or 0.50. So that writing that claim in symbolic form is critical to then be able to write the null and the alternative.
I thought it was supposed to be flipped.
Only when it has equality with it. See, there's the, I know.
Okay, so it's less
Yes.
or equal to.
Yes. If that original claim said at least or at most, I could have it equal to. It would have equality in that claim. That changes everything. It's less than half. Can it be half? If it says less than half? No, it's just less than half. If it had said is say that again. You mean the alternative hypothesis? Only when there's equality with it. Only when there's equality with it. Okay, so let's take a minute. Question 7 is exactly like this one. Good. So let's just add something here. So let's get these rules down. Maybe this will be better. Maybe this will help. Okay. If my claim says P is equal to, and I'm just going to put something down. That's my claim. My claim has equality and only equality. My null is going to be the same. Always equal. The null is always equal. Because this claim has equals and only equals the alternative hypothesis is P is not equal to 0.40. That's where we're going. We're going to put every single possibility up there. Okay? So then, let's say our claim, just like the one we just did, was that P is less than half. This does not have equality in it at all. There is no equality. Because there is no equality, I still have to have my null hypothesis as being equality. Okay? Because it's only less than, there is no equality there. My alternative hypothesis is going to be exactly the same. How about if we said a claim was that more than half? If I said more than half, is there any equality there? No. But my null hypothesis still has to have equality. Because there's not equality there, my alternative is going to be exactly the same. Here's where it flip-flops. This is why it's confusing. You've got to keep thinking, does the claim have equality? And that's key. So if my claim says the percentage or the proportion is less than or equal to 0.50, equality's there. My null hypothesis is still only got the equal sign. It can only have equality. Because my original claim says less than or equal to, this is where I'm going to flip it for my alternative hypothesis. We'll do the last possibility, right? No. Yeah, you cannot have any, you can never have equality in my alternative hypothesis, because then how would I know? If I had equal here and equal there, I wouldn't know. Okay? So my claim being that the proportion is greater than or equal to, again, the null hypothesis has to be equal to. And my alternative hypothesis, because it has equal and greater than in my claim, I'm going to flip it and have no equality. So it's going to be that P is less than 0.05. Okay, does that help? Again, that's why I say read the claim and nothing else, and then go from there. Okay? We'll have a lot of practice. Well, they didn't want me to go back. There we go. Okay. Okay. So back to number 14, we have our null and our alternative hypothesis written symbolically. We have a survey of 1,002 people who filed tax returns, showed that 48% of them file and through an accountant or other tax professional. And our job here is to find the test statistic. What am I using and why? Yes, I'm going to use the z-score because it's a proportion. That's the easiest one. If it's a proportion I know, boom, it's going to be z. Okay? And then my formula for the z, I'm going to try to squeeze it in here. P hat minus P. P hat is always my sample statistic, and it tells me my sample had 48%, correct? So I'm going to write 0.48 minus 0.50, all divided by, and I'm going to write P times Q. What was P? 0.5 times Q, which has to be 0.5. Then I'm going to divide by N. N was the number of people I surveyed, which happens to be 1,002. And what do we end up with? Negative 1.27. Okay? Negative 1.27. And knowing what we know about z-scores, that's not really extremely low, is it? It's probably more usual. So we would probably, what? Fail to reject the null hypothesis, which says it's about equal to. Okay? Less than half. Negative 1.27. Did we all get it? Negative 1.27 on our calculator, or we need to practice that? Okay? Does it tell you on your formula sheet? Z and T? There it is. On your formula sheet, it gives you the Z. Then it gives you T for the mean one population where sigma is unknown, sorry, and then use the Z where sigma is known. So it's right there on your sheet for you, your formula sheet. Okay? You don't have the same sheet. You don't have a front and a back. So how would you like to have a front and a back?
Some of them are all weird.
Yeah, sometimes, I know. No front and back?
Some of them are weird.
I have magical papers.
So we're looking at chapter 8.
You are. You're looking at chapter 8. Yep. Mm-hmm.
Let me see which one.
And these, by the way, are on your MyLabs Plus site. So if you want to print them out, you're certainly welcome to print them out. I just have them laminated so I can use them over and over and over and over again. Okay? We doing better? I said it just takes practice, thinking them through. Did I say number 15 is a no? Because the number 15 has to do with chi-square because it is standard deviation, so we're not going to go through that one. Then we have 16. Okay. White blood cell count. Again, we're going to read the claim, and that's it. Read the claim, write the claim in symbolic form. For adult females, the mean of their white blood cell counts is equal to 8.00. So are we dealing with a proportion or a mean? A mean. So the claim says that the mean is equal to 8.00. So my claim written in symbolic form is going to be that mu is equal to 8.00. Everybody cool? Okay, so I know the claim. I can write my null hypothesis. We know it has to be equal. We don't have a choice. And writing my alternative hypothesis. What am I going to write? Not equal to, because there was no inequality sign here. It was just plain equals. This has to say mu is not equal to 8.00. And that makes sense because I'm not saying that it's less than or greater than or more than or at least. I'm saying it's equal to it. Okay? Once I've done that, then I can continue reading here that the random sample of 40 adults, because I need to check this number, in the data set 1 from Appendix B has a white blood cell count with a mean of 7.15 and a standard deviation of 2.28. So this is where I have to decide which test statistic I'm going to use. When I'm doing mean, I have to decide, is it a T or is it a Z? So on your, still here, I have an extra one. If I look at number 8, chapter 8, T, a mean, right? And what does it say? If sigma, which is standard deviation, is unknown. And Z is if the population sigma is known. Do I know the population standard deviation? No. I know the sample standard deviation, but I don't know the population standard deviation. Does that make sense? When it tells me those two numbers, that is based upon what the sample is. Back here, where it talks about in general, they did not give me the standard deviation of the whole population. Everybody see that? Excellent. Okay, so therefore I know I need to use the T statistic. I need to use the T statistic. And my T statistic says, we'll write it up here just. This is my sample mean minus the population mean divided by the sample standard deviation divided by the square root of n. Population mean divided by the sample standard deviation divided by the square root of n. We did exactly what we just recently. Yes, everything just builds, doesn't it? Because we've talked about usual and unusual. We've talked about critical values.
I'm a little bit confused. So mu stands for, you said
Population mean.
population. That's what mu.
Mu is population mean. So in this example, what is the sample average? 7.15. Whoops. What is the population It went to sleep on me, I guess. It didn't recognize that I was actually doing anything. Yeah, well. Let's see if it brings it back up. Okay, and I'm still recording. I wonder what the people at home think about this. The whole screen just went blank, right? Okay. So we have that. We're going to divide by the sample standard deviation. And the sample standard deviation, I don't remember what it was. We can go back and look. 2.28. Square root of n, and the square root of n was 40. Here you need to put in parentheses. You need to put in parentheses. So I'm going to put a parenthesis and a parenthesis. I'm going to put a parenthesis here and a parenthesis at the end as I'm punching that in. Okay? If you have the older version where a square root comes up with a parenthesis and you type in 40, you have to close that parenthesis and then put another close of a parenthesis because that'll close this first one. Okay? If you have the newer operating system, you'll just cursor out from underneath of that square root symbol. It's what? Negative 2.36. Negative 2.36. That's going to be pretty out there, isn't it? Okay. All right, so we're not doing too bad. Is it getting better? Sure. You didn't get that one?
Unless I'm not doing.
Okay, divided by. Oh, you didn't get a divide by in between the 2.28 and the square root.
Oh, is that what that
Mm-hmm.
is?
Okay, everybody else get it okay on their calculator?
Let's figure out that
One little thing means a whole difference in the world. You got that right. You had 2.28 times square root of 40 instead of divided by square root of 40.
I didn't put the parentheses on the bottom part.
It came out okay?
Negative
Oh,
0.058.
yep.
So it was way different just because of the parentheses were around.
Exactly. Because what do those parentheses mean? It says divide this first, and then take this difference and divide by that. Correct. Aaron?
So when we get questions, I know this one gave us that the population standard deviation is not known. Will that be on all the questions? Like, will they tell us?
It will tell you. When it gives you the original, it'll say the mean is this and the or mu is this, or when they talk about the claim, it would have the standard deviation in the claim, and that means it's with the population. Then it goes and talks about the sample, so you know that the sample then, whatever it gives you there. Okay? Lots of little intricacies, right? Okay. The conclusion I'm going to think is going to be what? That we would what? Reject. But probably reject. I don't know what my alpha is. It's not telling me my alpha. Okay, so without the alpha, I can't truly make that statement. It does fall between -3 and +3, but I still don't know what my alpha is. My alpha, if my alpha was 0.1, I think that's like 1.645 and -1.645, so it would be below that. Yeah, so we really need to know what our alpha is to truly make that. But being that far down, I would say we probably reject. Depending, again, it all depends upon that alpha. What level of significance we're testing at. Don't worry, we're going to do some that will help us determine that, and then we're going to do the whole full-fledged thing from start to end. Didn't I tell you, so this was the hardest part. We'd get through it one step at a time. And after this, 10 is like rolling downhill.
Right, roll it.
You're ready to roll downhill. We're almost there. We're almost there. You're past ready for that. I know it's hard. This is like week what? 13. Week 13. I know. Counting this week, 4 weeks, and next week we have 3 weeks to go. You know, get that last college effort. You can do it, right? I know. Okay, so in these exercises, now we're looking at whether we are going to, well, we got to find out what our p-value and our critical values are. So we're using the significant level of all of them are going to be alpha is equal to 0.05. Okay, so the test in 17, the test statistic of z is equal to 2.00 is obtained when testing the claim that p is greater than 0.5. So we want to know a lot of things about this. First, being that my claim is that p is greater than 0.5, what's my null hypothesis? P is equal to 0.5, and my alternative is p is greater than 0.5. So now that I know those, I have to decide what my p-value and my critical values are. So, is this a one-tailed or a two-tailed test? It is a one-tailed test, isn't it? The only time I'm going to have a two-tailed test is if it says is not equal to. Okay? So to find my p-value, and again, don't be sloppy in your work because the p's fly all over the place, right? You got p, which is a proportion of the population, p hat, which is the proportion of the sample, and now you have a p-value. Label, label, label. So my p-value, we're going to find that p-value for when z is what? Or really bigger. So how am I going to do that? What is that really saying? We've done this since we started with the normal curve. It's just different terminology. Really, we're saying, what is the probability in that tail when my z is at 2? So I really want to know the area under the curve, right? That's when z is 2. Back to drawing pictures. So when z is 2, if this is 0, where's 1, here's 2. Really what it's saying is I want the area under the curve I want this little area under the curve. That's what the p-value is. So on your calculator, isn't it nice to get back to your calculator? We can find the area under the curve. Everybody remember how to do that? Second, distribution. Number 2, the normal curve. I've got to put my lower and my upper. My lower is at 2. My upper is at 9999999. And I am on this normal curve, so mu is 0 and standard deviation is 1, and I find the area of that curve, under the curve at that point is 0.022, we can round that to 8, 0.228. 0.228. I wrote it wrong. Yes, go ahead. 0 for the mean for mu and 1 for the standard deviation.
So that's the p-value.
So my p-value is 0.0228. So right then and there, if I'm testing at an alpha of 0.05, is 0.0228 less than 0.05 or more than 0.05? Less. Is it going to fall in this area? Yeah, it's going to fall in that area. That would mean what? I'm going to reject my null hypothesis. I'm going to reject my null hypothesis. This is where HO would be. This is where I would reject. This is 0.020 is way up here, and my p-value is this. It's less than this. It's going to be way up there. Okay? So that's one way I can do, and I did find what? My p-value. I haven't found my critical values. My critical values are my z's. Critical values are my z-scores. Let me come down because I'm so out of room. Okay? We'll try to put it all on one curve. That's 0. So first what we did, this is exaggerated so I can have big blow up to show you, right? We found the area under the curve where the probability of getting it would have 2 or more, because my test statistics said z was 2. Okay? When we did that, we found this area was 0.0228. My alpha is at 0.05. Since this is my p-value, I know right now I can reject the null hypothesis because it's way down here less than my alpha. Okay? This is my p-value. The other thing now I need to find is something that's called critical values. And we've already found them before. Critical values are z-scores. Critical values are z-scores. This is a one-tailed test, right? We've already discovered that. Alpha being 0.05. Would I have to shade a bigger area for alpha to get 0.05 area? I'd have to shade a bigger area, right? So it's going to be somewhere in there. I don't know where yet. So how am I going to find that?
I have a question. If alpha is 0.05, so wouldn't it be less than 1? Like,
But this is a one-tailed test to be greater than. So it's alpha being 0.05 on this side. If it was a less than, it would be alpha of 0.05 on this side. Okay? So I need to find the z-score where 0.05 is to the right of z. Remember that's really what we're asking for. Find the z where the area to the right of z is 0.05. That's really what we're asking for, isn't it? We can do that on our calculator. It's inverse norm. Inverse norm. Second, distribution. Remember that this feature of my calculator wants the area. The only area it takes is what? From the left to the z. So I have two choices here. I can punch in 0.95 and it'll give me that positive z. Or I can punch in 0.05 and it's going to be the negative, but because of symmetry, it's still going to be the positive, right? So either one I can punch in. It's going to give me a positive or a negative. So you don't even have to do the math, right? What do I get? Negative 1.64. But it's really going to be what? Positive 1.64 because this right here. Okay? So regardless of which method, these are two methods to do the same thing. The critical value method and the p-value method. Okay? The critical value method and the p-value method. The p-value is I'm going to find the area and compare it to my alpha. The p is nothing more than the area from the z beyond. Critical value is I'm going to find the z-score, which is the critical value of alpha, and then I can compare z-scores. They're both going to give me the same result. In this case, I would reject the null hypothesis. I would reject the null hypothesis because I'm over here. I'm not in this area. To not reject, to fail to reject. Bless you. Because my statistic fell right here. My test statistic fell right there. In the green is where I'm going to reject. If it were over here, I would fail to reject. Yes. If my if my p-value came out to be 0.051, I would fail to reject because it's more than alpha. If my z-score came out to be 1.63, I would fail to reject. Let's do the next one. I don't even know what the next one is. Here we go. So now, we can probably just do this one right in our heads, right? Because what is this? It's just taking the opposite end when it's less than. It's going to be the same result. Number 19 says the test statistic of z is equal to negative 1.75 is obtained when testing the claim that p is equal to 1/3. P is equal to 1/3. So this one's going to be a little different. I'm going to get to a new page because I know I'm going to need the room. Negative 1.75, is that right? And the claim was P is equal to 1/3? Okay. Is that a proportion or is that a mean? Proportion. So I know I have to use Z, right?
Special proportion
Mhm.
is not a proportion. You use
Okay. If it's a mean, then I have to determine. If I know the standard deviation of the population, I use Z. If I don't know, then I use T.
So will we ever really use these other ones, pushing it with one population? Or will we ever really use this one here?
Yeah,
Sometimes?
because that's for the proportions. That's what we're using right now
Oh, okay.
for proportions. Yep. Okay.
Seems like it's like
It's a lot of steps. It's a lot of lots and lots of steps. Okay. What is my null hypothesis? P equals 1/3. What's my alternative hypothesis? Okay, alpha at 0.05. Okay. Is this going to be a one-tailed or a two-tailed test? Two-tailed. Two-tailed test. Okay. So I've got a little bit on this side and a little bit on this side, right? So what am I going to do if alpha is 0.05? I'm going to divide 0.05 in half. I'm going to divide 0.05 in half because I've got to take my alpha and cut it for part on this side and part on this side because it is a two-tailed test. It's a two-tailed test. So the area there is 0.025. The area here is 0.025. Now the thing that you have to remember with a two-tailed test, we've got to multiply the p-value times 2. Whatever we get, we have to multiply the p-value times 2. So to get my p-value, I know my z is negative 1.75, correct? So the probability where z is really less than negative 1.75 is really what I'm going to be putting in my calculator, right? Because I know my z. That's my test statistic, and it's going to give me back my area. But because it's in two tails, I've got to multiply that by 2. Okay? So let's go to our calculator. Again, we're looking for that area. Second, we're going to come down here to inverse norm. What am I putting in for my area? Oh, I'm sorry. I'm going backwards, aren't I? I want to do the normal distribution. I was getting ready to get my p-value, wasn't I? I mean my area there. Second distribution.
Negative into negative 1.75, and that'll give you the one to the left. And the city needs to multiply that by 2, that'll give you both of them.
So I'm going to put that in, come down, and when I get that answer, my answer is 0.0401. So it's 2 times 0.0401. So I'm going to end up at 0.0802. What's my alpha?
0.025.
No, that's my area. My alpha is still 0.05. Is that more than 0.05 or less than 0.05? More. That means it's in this area, right? That means I fail to reject the null hypothesis. So now I've done it by my p-value method. But I want to find my critical values. I want to know, what is my z right here? What is my z right here? I want to know that's the critical value method. You're going to get the same result. Fail to reject. So now in my calculators, I'm going to go to second distribution and find the area, which is inverse norm. What is the area? 0.025. I'm going to come down, and I'm going to get negative 1.96. Negative 1.96, and so this one is positive 1.96. What was my z-score? Negative 1.75. It falls in this region, doesn't it? So I am going to fail to reject. If I had fallen outside of the region, I could reject it. But because I fell inside the null hypothesis region, I'm going to fail to reject it. So I get the exact same result using both methods. Say that again? But I will ask you for both. When I lead you down on your test, when I lead you down that test and I go, state the claim in symbolic form, give me the null hypothesis, give me the alternative hypothesis, I'll say, what is your p-value? What are your critical values? And then you'll decide to reject or fail to reject, and then you'll have to write your conclusion. Okay?
When we were doing the normal curve, I just need a refresher all about to put negative 999.
Because I'm coming from negative way out here, and I want all this area. So I have to give a boundary. So negative 99999 is out to maybe almost not negative infinity, but we want to get it there, and up to that point. And that gives me the area between that, and it tells me my z.
That was the point I was thinking the same thing, and then you would do the same thing. Instead of it being, it would be positive 99.
Right. My lower would be 1.96 and my positive.
The same thing. Why did someone like asking a whole bunch of questions?
No, you need to ask the questions.
I was thinking, why can't you do the lower as negative 1.96 and the upper as 1.96? But that's looking for the in between.
That's looking for the in between. Yes.
Gotcha.
Lower and upper edge. Okay. Is it getting better? Kind of. You need a step sheet next to you. I get it. I get it. I know. It's a long process, and the best way to get it is just to keep practicing and practicing. So I think then what I'm going to do is have you guys work together and do problems 20 through 24. And that'll be from now to the end of the class. And then if you would try to do for homework, what other ones did I give you? I might be telling you something I didn't give you.
7.4, and then we have an exercise 24. by the 28, assume a significance level and use the given information for the stating conclusions section.
Okay, the rest of these in that first one, I guess it was 20 through 24. Okay, and then you can get those done before, as a group then before the end of class. And then for homework, make sure you do that 25, 26, and 27. When we come in on Monday, because that'll get you through all the steps. We come in on Monday, we're going to be pulling problems from 8.3 and 8.4, which are going to be using a mean or a proportion, and we're going to take one problem, we're going to go through from beginning to end. From beginning to end, several problems that will work together to do that, okay? But now if you do those, you'll have all those steps that you've practiced before we do beginning to end, okay?